Agent and environment are the two major components of reinforcement learning. So let's see how agent and environment interact. At each time step T, agent executes an action A and in turn receives a reward corresponding to previous action and some observation. And what environment does? It receives the action and emits an observation OT plus 1 and RT plus 1. So whatever action the agent took in the previous time step, the environment sends a reward for that in the next time step and also the corresponding observation, and we increment T at the environment step. So reward is a scalar feedback signal and it indicates how well the agent is doing at time. So it will be useful in comparing which reward is better, R1 or R2. So we should be able to put different rewards on some scale so that we can compare rewards, which will help the agent in optimizing its policy. So the policy which will yield more cumulative reward will be a better policy. So the main goal of agent is to maximize the cumulative reward over time. So it's not necessary that the immediate reward should be maximum. So that's why it's different from a greedy algorithm. So the goal is to maximize this cumulative reward over time. And we call this cumulative reward as return. Reinforcement learning is based on a reward hypothesis. And by reward hypothesis, we mean that any goal can be formalized as the outcome of maximizing a cumulative reward. Let's see some examples of reward. So in case of chess, we can define a positive reward for winning the game and negative reward for losing the game. So you see that here for individual moves, we are not giving any reward and the reward is delayed and we may get the reward at the end of the game. So it's not necessary that after every action there will be a corresponding reward. Second example could be learning the robot to walk, making the robot to learn to walk, where we will give positive reward for forward movement and negative reward for falling. And in case of helicopter maneuvers, we can give positive reward for following the trajectory. If the helicopter follows the desired trajectory, it will receive positive reward, whereas negative reward for crashing the helicopter. We saw that different problems can be formalized under the reinforcement learning. So are these problems very different from each other, or can we find something common to these? So we used sequential decision making for unifying them under some common goal. So the common goal for all of those tasks was to select actions which will maximize total future rewards. So we may have to plan ahead. For example, sometime the reward may not be obvious immediately. For example, in the case of game of chess, we will receive the reward only after winning or losing the game. So we may have to plan ahead. So the results may be delayed and we may need to sacrifice immediate rewards for better long-term rewards. So some example could be that some moves in chess may not be obvious, but it may be useful in the long run in winning the game. Similarly, in financial investment, we give up some money in the current time, so we kind of get some negative reward, hoping that we will get bigger positive reward in the future. Similarly, we spend on education, hoping that the return would be much more than the current expenditure.